Okay, we're going to pick up with part 2 of balancing chemical equations. So we already did the first video where we talked about the basics for the method of how that is achieved. We're going to move on to looking at some more complex problems. So here we have lithium, and it is in a displacement reaction where it is replacing some hydrogen. So looking at that equation, let's go ahead and let's set this up with the little chart that we make at the beginning. So we're going to list our elements. We have hydrogen, lithium, phosphorus, and oxygen. And so we just need to count all of our atoms for each element. So here I have 1 lithium, over here I have 3, over here I have 3 hydrogen, over here I have 2, 1 phosphorus and 1 phosphorus, and then 4 oxygen, 4 oxygen. Remember, if there's no coefficient, you can imagine that it's 1, and if there's no subscript, you can imagine that that is 1 as well. So looking at the problem, I know that I need to have more lithium over here. So I'm going to go ahead and increase the amount of lithium I have. And that changes the reactants to 3 lithium. Looking over here, I'm having an issue with my hydrogen. So what I can do is I can think in terms of least common multiple. If I place a 2 here, then that's going to give me, well, actually that's going to change a lot of things. It's going to change everything but the lithium. So now I have 2 times 3, which is 6 hydrogen. I have 2 times 1, which is 2 phosphorus, and 2 times 4, which is 8 oxygen. Now on this side, I need to do a couple of things. First of all, I can place a 3 here, and that's going to give me a total of 6 hydrogen. As far as all the rest of these elements are concerned, they are all going to have to change, because if I place a coefficient at the beginning, it changes all the elements that follow. So let me strike that real quick. I'm going to place a 2 here. So that's going to give me 6 lithium. 2 times 1 is 2 phosphorus. 2 times 4 is 8 oxygen. So it looks like everything's okay except for the lithium that I had over here when I began. Here I have 6, there I have 3. So if I can double that number, so 2 times 3 is 6, I can now have a balanced equation. As you can see, all the elements on both sides of the equation are even and everything is equal. Okay? So again, you're going to have to erase, maybe go back sometimes, and that's okay. I mean, this is not something that's just simple. You have to kind of think about everything that you're doing. Okay? All right, next problem. Here I have some iron oxide, and it's going through a reaction, and it's creating carbon dioxide in the process. So I'm going to list my elements: iron, carbon, oxygen, just like that, being a little neat with my chart here. Let's just kind of look at what we have currently. So I have 1 carbon and 1 carbon. I have 2 iron, 1 iron, and I have 3 oxygen, and I have 2 oxygen. So go ahead and pause the video real quick, take a moment to see if you can solve that, and then we will come back and look at our solution, and you can see if you were correct or incorrect. Okay, now let's look at what we should have for this. So I know that immediately I need to kind of think about this oxygen here. So that's a problem, and if you look at these two, you need to think that the least common multiple is 6. So think of a way to make both of these 6. And the way that you would do that is by placing a 3 here and placing a 2 there. Now, when that happens, a lot of things change. So let's just kind of go through this and do it over again so we can see what our numbers would be. So I have 2 times 2, which is 4, 2 times 3, which is 6. Over here I have 1, and then I have 3 carbon, and 3 times 2, which is 6 oxygen. Now, because the carbon and the iron are by themselves, it's very easy to balance this equation. All I have to do is place a 4 here, and so you now see that I have 4 on both sides, so that is balanced. And this, and first of all, my oxygen, those are balanced already, so I just need to look at carbon right here. Because I have 3 on the right, I can just place a 3 for my coefficient there, and that equation is now balanced. I hope that you got your answer correct when you were trying to solve this on your own. Let me erase this and we'll look at another example. Alright, so here I have zinc sulfate, and I have oxygen gas, and that's becoming zinc oxide, and then we have a covalent compound right next to it, sulfur dioxide. Alright, so let's list our elements. We have zinc, oxygen, sulfur. Alright, so let's just count what we have. We got 1 and 1, we have 2 and 1, we have, I'm sorry, that's not 1, we have 2 over there. And then we have 1 sulfur and 1 sulfur. So everything is looking okay with this. Do you see any issues? So this is an example of one that is already balanced. So I have 2 oxygen, 1 zinc, 1 zinc. Oh, wait a minute, that's not true. I don't know if you noticed this or not, but there's 2 places where we actually have oxygen. So we have to add those 2 together. We have 1 here, 2 there, 3. Now I hope some of you caught that when you were looking, because you will have examples like this. You cannot just look at one simple compound. On the entire side of products, you might have different compounds that contain the same element. And if you have that, you're going to have to combine those quantities together. You're going to have the sum. So my total here is 3. So to solve this, I need to think about, again, you want to think in terms of least common multiple. And the first thing you do, so really, if I can make this a 3, then I would solve that. The whole thing would be balanced. So what I can do here is I know I need 3 oxygen. If I place 3 over 2, and I'm getting that denominator from the subscript here. If I place 3 over 2, I'm going to be able to balance this, and I'm going to show you what I'm going to do with that. So from your mathematical skills, you know that if you're going to want to eliminate that 2 as a denominator, you need to multiply both sides of the equation by 2 using that distributive property. I need to multiply that by 2, that by 2, that by 2, and that by 2. So let's go ahead and let's do that and let's see what happens. So I'll place a 2 here, I'll place a 2 here, I'll place a 2 here, and then I'll multiply 3 halves by 2. And when I do that, I get a 3 here. So 3 halves times 2 equals 3. So now let's look at our numbers again. And let's see what we have. So I have 2 zinc, I have 2 sulfur, 2 sulfur, I have 3 times 2, which is 6 oxygen, and then I have 2 oxygen plus 2 times 2, which is 4 more, which equals a total of 6. And so now you can see that all 3 elements are balanced. I hope you enjoyed this video today. I hope that it helped clarify some things that you might not understand. And you know, this is not something that's very easy. You do have to practice to get good at it. And you know, you have to slow down, go through your steps. Remember that you want to save the solo atoms for last. You want to think about least common multiple. And you want to check each element on both sides, and that you can never change subscripts. You can only manipulate coefficients. Oh, but wait, there's more. So here we have iron sulfate, chlorine gas, becoming new compounds on the reactants, I'm sorry, the product side. So how would we solve this? And I'll give you a hint. This is another one that you're going to have to use fractions with. So we have iron, sulfur, chlorine. And again, you have two places where you have the same element on the same side. Alright, so let's go ahead and let's count what we have. We have one iron. In the total side we have one iron. Over here we have one iron. We have 2 chlorine. We have 3 plus 2, which is 5 chlorine. We have 2 sulfur. And we have 2 sulfur. So as you can see, it's looking like it's almost balanced. The only thing here is that if I had 5 chlorine, it'd be perfect. Because I have a subscript of 2, I'm going to write 5 over 2. So think about this. 5 times 2 is 10, divided by 2 is 5, so I would have 5 chlorine over here. So now I'm looking at this, and it's looking like if I could, if I could place that number there, then that would be perfectly balanced. As you can see, these are okay. So again, to get rid of this, because you cannot have that in your final answer, I have to multiply all 4 of these compounds by 2 by placing a coefficient of 2. So 2, 2, 2, and then 5 halves times 2 is 5. Now I can look and see what my quantities of atoms are and check my answer to make sure it is correct. So I have 2 times 1, which is 2. 2 times 1, which is 2. So iron is good. Sulfur, 2 times 2 is 4. 2 times 2 is 4. And that is the only place where I have sulfur on my product side of the equation. Now let's check the chlorine, because that was our problem. 5 times 2 is 10. It's a lot of chlorine atoms. 2 times 3 is 5. 2 times 3 is 6. And then 2 times 2 is 4. And as you can see, I have a total of 10 chlorine. So that was a pretty complicated one for 2 reasons. First of all, you had chlorine in 2 different places. And then secondly, you had to use a fractional quantity to solve that. Thank you for watching.